Good morning, students. Today is the 15th session, and the topic which we are going to discuss is going to be coordination chemistry. So in this class we will be discussing regarding valence bond theory, inner and outer complexes with coordination number 6 of cobalt. So I'll be discussing the inner and outer complexes of cobalt with coordination number 6. Recollecting the valence bond theory, which states that the central metal ion in the complex will make available adequate number of empty orbitals for the formation of coordinate bond with suitable ligands. Appropriate atomic orbitals of the metal will hybridize to give hybrid orbitals. The hybrid orbitals are going to be directed towards the ligand position according to the geometry of the complex. Each ligand has at least one orbital containing a lone pair of electrons. The empty hybrid orbitals of the metal will overlap with the fully filled orbitals of the ligand to form ligand-metal coordinate bond. If the metal is going to use its inner orbitals, that is n-1d orbitals, it will be called an inner complex, and if it is going to use the nd orbitals, it will be called an outer complex. So if n-1d orbitals are used, the hybridization involved is going to be, if it is going to use 2 d orbitals, 1s and 3 4p, it will be an inner complex with d2 hybridization. But if it is going to use 2 of the d orbitals, 1 4s and 3 4p, the hybridization formed is going to be sp3d2, because it is using the outer d orbitals. It will be called an outer complex. So d2 sp3 hybrid orbitals are inner orbital complex, and sp3d2 are going to be the outer orbital complex. So in today's class we are going to mainly deal with the inner complexes, inner and outer complexes of cobalt with coordination number 6. So first, considering one example for inner complex of cobalt with coordination number 6, let us study an example that is hexaamine cobalt 3 complex. Cobalt has atomic number 27 and its configuration is going to be argon 4s2 3d7. In the formation of hexaamine cobalt 3 complex, cobalt has +3 oxidation state. Cobalt has +3 oxidation state. Here it is going to use 2 of the 3d orbitals. So it is going to use 2 of the 3d orbitals, 1 4s and 3 4p orbitals are used in the hybridization to form d2 sp3 hybrid orbitals. These d2 sp3 hybrid orbitals are going to be directed in an octahedral geometry, as it is using n-1d orbitals for the formation of d2 sp3 hybrid orbitals. It is an inner orbital complex, and we observe, and in this case there are no unpaired electrons, so it is going to remain diamagnetic and a low spin complex. So in the +3 oxidation state, cobalt loses the 2 4s electrons, 1 3d electron, and it will be having 4 unpaired electrons in the 3d orbitals. Now, as the 6 pair of electrons are going to come from the ammonia molecule, what happens is these electrons are forced to pair up, and the hybrid orbitals are going to overlap with the 6 pair of electrons of ammonia molecule. So it is having no unpaired electrons, it is diamagnetic in nature with a low spin. Coming to the outer complex of cobalt with coordination number 6. Cobalt with atomic number 27 will have argon 3d7 4s2 as its electronic configuration. In the formation of hexafluorocobalt 3 complex, cobalt is present in +3 oxidation state. So even in the formation of this complex, cobalt is present in +3 oxidation state. But during hybridization, it is not using the inner d orbitals. It uses the outer d orbitals for hybridization. So it will be called an outer orbital complex. So here it uses 2 vacant 4d orbitals, 1 4s and 3 4b orbitals are used in the hybridization, and it undergoes sp3d2 hybridization and forms 6 sp3d2 hybrid orbitals. These hybrid orbitals formed will be directed in an octahedral geometry. As it is using the nd orbital, it is going to be an outer complex. It has unpaired electrons, so it is paramagnetic in nature, and it is going to be a high spin complex. If we look at cobalt atom, in its ground state it has got 4s2 3d7. In the formation of iron 3 or in +3 oxidation state, it loses 2 4s and 1 d electron, and it has got 4 unpaired electrons in the d orbital. But in this case, it is not using the 3d orbitals or the electrons are paired up. In fact, it is using the outer d orbitals. It is using the outer d orbitals. It undergoes sp3d2 hybridization using 1 4s, 3 4p and the 2 of the 5d orbitals. It forms sp3d2 hybridization and undergoes sp3d2 hybridization. The 6 hybrid orbitals formed are oriented in an octahedral geometry. These hybrid orbitals are going to overlap with the fluoride ions containing a lone pair of electrons to form hexafluorocobalt 3 complex. So what did we study is hexaamine cobalt 3 is going to be an inner complex wherein it is using D2 sp3 hybridization. It is using D2 sp3 hybridization. There the electrons in the d orbitals are forced to pair up, and it is not having any unpaired electron. It is going to be diamagnetic in nature, a low spin complex, whereas hexafluorocobalt 3 minus is going to be a complex with outer. It is going to be an outer orbital complex. Here it is using the outer d orbitals, and it is undergoing sp3d2 hybridization. The hybrid orbitals even in this case are going to have an octahedral geometry. As it has got 4 unpaired electrons, it is going to be paramagnetic in nature, and it is a high spin complex. Okay, thank you.